Again, the title of today's presentation is CPE Metadata Know-It-All. In the fast-paced environment that we operate in, whether it be that you're managing security vulnerabilities, improving compliance, or enhancing your IT systems, I think knowing a little bit more about CPE metadata could help you build a more robust vulnerability management process. So a little bit about me before we get started. I'm an InfoSec engineer at MongoDB. I've got previous experience in risk assessment and management as a consultant in one of the big 4 firms. But now my focus is primarily product security, where I lead the MongoDB bug bounty program and the CVE disclosure process. I've come from London, and throughout this presentation, we're going to explore what CPE metadata is, its crucial roles, and other discoveries as part of my research into the topic. Okay, so before diving deeper into the topic itself, I did make a little assumption that the listeners of today's talk will have some background knowledge on the CVE world and all the acronyms that come with it. It is a lot of acronyms, but a little bit of like a overview of what these are. So CVE stands for Common Vulnerabilities and Exposure. It's basically a list of publicly known security vulnerabilities. And within the CVE, it contains characteristics or metadata that we will be discussing today. So some of them are CVSS, which stands for Common Vulnerability Scoring System, CWE, Common Weakness Enumeration, CPE, which we will talk about today, MVD, National Vulnerability Database, and lastly, CNA, which is the CVE numbering authority, which basically allows organizations to issue CVEs. Okay. Okay. What is CPE? In more detail, CPE stands for Common Platform Enumeration, and it is a scheme developed by MVD, also known as the National Vulnerability Database, and they're a supporting body of the CVE program. So they created the scheme to provide standardization and structure for information technology systems, software, and packages. And in even simpler terms, it's a standardized naming system for a software or hardware down to the specific version or the configuration of that product. So why is it important to have a standardized naming system? And CPEs are a very easy way to enable organizations in security management. They allow security professionals and tools to identify and manage vulnerabilities in their systems down to the specific affected product and version. They also provide consistency in naming within and between organizations. And then lastly, they also help with automation. So with these standardized identifiers, automated systems can process security alerts more efficiently. Okay, so not only are CPEs created by MVD, they're also maintained by MVD through an invaluable resource called the CPE Dictionary. And this dictionary compiles of all known CPEs, serving as a database where you can locate the CPEs of any product that has had a CVE issued. To make the most of this resource, organizations can access this dictionary via the MVD APIs, or you can download it directly on their website. So all CVEs, when they get published, at some point, they get analyzed by an MVD analyst. And those analysts, they add metadata, and including CPEs. And once these CPEs are included, they get updated into the dictionary, and the dictionary is updated daily. Okay, so I briefly touched on CVEs throughout this, and why are they also very crucial? I wanted to break it down into a simple concept of who, what, where, and how. So firstly, addressing the who, which is a security vulnerability. every security vulnerability publicly known gets assigned a CVE. And at its core, CVE contains the title and description of the vulnerability, but it also holds essential characteristics of the vulnerability. In this case, we'll be calling them metadata. Next, we have the what. This represents the CVSS score, and it tells us the severity of the vulnerability, providing a quantitative measure to allow you to assess its impact. And then we have the where. This is the CPE indicating the affected product and version. So it helps you pinpoint exactly where the vulnerability exists in a system. And then finally, how. This is captured by the CWE, Common Weakness Enumeration, and it describes a weakness that led to the vulnerability. So a lot of people actually depend on this data. And historically, MVD has been a key provider of enriched CVEs, specifically the CVSS and the CPE. These characteristics and metadata are essential for CVE consumers. Our research has found that vendors are quite reliant on this metadata provided by NVD, where vulnerability scanners use these metadata in their tools in identifying and managing vulnerabilities. Okay, so what's the problem? Every good story has a challenge. So in early 2024, NVD announced that they will be slowing down its process in enriching CVEs with crucial metadata like CVSS and CPEs. Now, this announcement led to discussion within the industry about how it impacts the users. And particularly for us at MongoDB, we were curious how it would affect our customers and the user experience of CVEs. Essentially, the slowdown meant that the addition of necessary metadata might not be happening as swiftly or as comprehensively as before, meaning that vulnerabilities might be miscategorized or even leaving systems still vulnerable. So CNAs, they can issue CVEs using the JSON schema created by the CPE program. But here's something quite interesting. CNAs are not required to apply metadata when issuing CVEs. But support for CVSS and CWE metadata is quite well known. However, CPE metadata doesn't get as much attention, even though the JSON schema itself accommodates the publishing of CPEs in them. Now, looking at the table, historically, over 50% of all CVEs have included CVSS and CWE. This is probably because the usage of them in daily operations is more common. But the kicker is that only 13% of 13.3% of all CVEs issued contain CPEs. Now, this gap highlights an area of improvement, definitely when it comes to vulnerability enrichment. And so then another question arises, if NVD doesn't do this, then who will? Okay, over the past few years, the number of CVEs issued per year has been growing at an accelerating rate. And historically, the issuance of CVEs showed modest numbers of around or under 10,000 CVEs per year until 2017, where there was a pivotal doubling of the CVEs issued compared to the previous year. So this could be because there is a rising awareness of CVEs and the need for cataloging vulnerabilities. And then since then, there has been a steady increase until 2024, where there was a 38% increase compared to the previous year. Now, this isn't as much as double, but as the global community becomes more familiar with the essential roles of CVEs in security management, this trend is likely to continue. And then crucially, the number of CVE numbering authorities, aka CNAs, underscores this trend. So you can see on the graph in blue, showing the total number of CNAs at the end of every year, almost mimics the trend of number of CVEs issued that year. If we look at the most recent years, in 2022, 54 CNAs joined the group, followed by 84 in 2023 and 88 in 2024. At time of data collection in 2025, there are 447 CNAs. But only a subset of these CNAs can issue CVEs for entities outside of their immediate offering. This suggests that there are potential vulnerabilities not yet documented, as there are billions of products out there. And then we have to tie it back to CPEs because that's the title of the presentation. As mentioned before, the CNAs use the JSON schema set out by the CVE program. They publish CVEs via JSON files, and these files can be accessible on the CVE page, but also on the CVE program GitHub public repo. So I've been able to pull that data to read the JSON files and created this graph, which is very similar to the previous graph, but each bar is separated into two segments. So the teal segment covers the JSON files that have the number of JSON files that have CPEs in them. And then the orange segment shows those files without CPEs. Now, there is an assumption that this orange segment is enriched by MVD themselves, suggesting the substantial effort by MVD in manually adding those CPEs for those CVEs. Now, if we look at the teal segment over the years, we also notice a slight increase throughout the years, but significantly, there was a spike in 2023 and 2024. So historically, the percentage of CPE inclusion remained around 10% or below until 2023 and 2024, where it increased to 26% and 54% respectively. The percentage increase in 2024 over doubles compared to 2023. And this could be because of MVD's announcement of slowing down its metadata enrichment. So as MVD continues to refine its processes, it's crucial to address the potential widening gap that could occur if the CVE issuance rates continue. So that orange segment could potentially increase throughout the years. And actually, in a talk yesterday by Andrew, one of the very first talks in the morning yesterday, he mentioned that the MVD and even CISA, they're struggling with vuln enrichment. So I suspect that orange segment will increase. Here I wanted to share that there are actually quite a few CNAs already self-enriching, and I've listed the top 5 in terms of volume, including CPEs in their JSON files. Now, it's also important to mention that although CNAs might have a history of adding CPEs, they might not be able to do so for all the CVEs that they issue. And this could be due to their roles. So I've mentioned before, there are 447 CNAs in total, and we found that 288 CNAs are issuing CVEs with CPEs in them. Now, this is 64%, and initially this looks like a really strong number, but when you compare it to the percentage in 2024, there were only 54% of CVEs that included those CPEs. And then when you compare it to all CVEs issued ever, it's 13.3%. Now, why is there that huge discrepancy? And this, again, could be due to the roles that the CNAs have. Some of these CNAs are issuing CVEs for organizations that don't have the CNA status themselves. And we know that adding CPEs can be quite labor intensive, since it requires a bit of research and creating those CPEs for the specific product. Our research actually didn't dive deeper into the decision-making behind why they would include CPEs for some and not others. But again, this inconsistent number could be due to the fact that that addition requires a lot of manual work. Okay, To bridge this gap in CPE inclusion, increasing awareness and understanding of CPE metadata among CNAs and industry stakeholders can ensure more comprehensive data is available from the outset, from the get-go, rather than post-publication tweaks and enhancements. So besides spreading awareness, we encourage that all CNAs include CPEs in their CVEs, and making CPEs more noticeable and familiar within those JSON files will ensure vulnerability scanners pick them up rather than depending on the metadata provided by the MVD APIs. So pushing this widespread CPE integration alongside metadata, alongside other metadata, we're prioritizing security, we're doing right by our customers, and we're also enforcing the idea that enrichment equals enablement for everyone involved. MongoDB has had a long history of self-enrichment in CVEs, and historically we have only been issuing our CVEs with CVSS and CWE, again, because they were more common. But in response to MVD's announcement, we saw that there was an importance to include these CPEs to better serve our customers. So what does it actually look like? As a CNA, we have the ability and responsibility to issue CVEs using JSON files. And the schema actually accommodates all the metadata we've discussed, including CPEs. And specifically, the schema features an affected section with an array called CPEs. And this is where you just copy and paste the CPEs into. Now, right now, our approach is fairly manual, but we maintain our own CPE database, and we update that based on our own product releases. And it's just a simple Google Sheet, so we can copy and paste the CPEs into the JSON files. So the initial setup is quite manual because you have to parse through the CPE dictionary, find the CPEs already available for your product so that you maintain consistency. But once you've done that initial setup, like the maintenance is quite straightforward and quite easy. Okay, I've spoken a lot about CPEs, but this is what they look like. This is a basic structure of what a CPE would look like, and essentially you fill in those gaps. Taking one of MongoDB CPEs as an example, the format starts off with CPE 2.3, which basically tells us that we are using the 2.3 version of the CPE specification. So the version is quite important so we can maintain consistency across systems. Following that, you have the part component, and in this example, it identifies the type of entity, which is application A. And that separates it or distinguishes it from an operating system O or hardware H. And then following that, you have the vendor component, where here we have MongoDB specifying that MongoDB is the vendor. And then after that, we have product component, which here is the Rust driver. So in this instance, we are pointing to the Rust driver developed by MongoDB. And then you have the version component, which here is 0.10.0. And this is crucial for patch management and vulnerability assessments. So far in this CPE, we've specified we're using the 2.3 version of the CPE specification. The product is the Rust driver version 0.10.0 developed by MongoDB. Now, the rest of the components are optional. So things like update, addition, language, they allow flexibility and specificity if and when needed. But in our example, it's represented by wildcards. And they serve as placeholders for unspecified values. In this specific example, we have MongoDB, which is in the target software location. And this is a little bit weird because when we looked into CPEs created for MongoDB, we have a product called MongoDB Server. And for some reason, the name of that product in the CPE specification, like in the CPE dictionary, was just MongoDB. So here we are saying that the Rust driver developed by MongoDB is to be used on MongoDB server. But for some reason, the history is that MongoDB is MongoDB server as well. Again, highlighting the need for CNEs to be creating their own CPEs, just so that we can provide that extra level of detail. But yeah, understanding the structure allows you to effectively use CPEs in security management and ensuring accurate identification of products for vulnerability assessments and communication. Okay. So as we've discussed, CNAs have the ability to enrich their own CVEs thanks to the permissions under the CVE program, who sets out the standards and the rules. But it's also important to point out that MVD themselves are not a CNA or an authorized data publisher, which is another status created by the CVE program to help with CVE enrichment. But MVD has played a huge role in the CVE system and the broader vulnerability management field. Their APIs provided very key metadata that many vulnerability scanners use. And as the industry is changing fast, we think it's really important that CNEs add their own details to their CVEs. So when you're working on CPEs, first you have to make sure that there's not already a scheme present for your product. This keeps everything consistent and with existing product versions. But if you have a new product that isn't listed, you can create a CPE and add it to the CVE JSON file yourself. That should update everything accordingly, including the CPE dictionary. The recent slowdown with NVD showed us, again, why it's important to manage this process ourselves. Since CPEs haven't always been well known, it's clear how valuable they are. I hope this message is quite going through, like I'm drilling it quite a bit. We should be self-enriching and encouraging our CNAs to include CPEs in our CVEs. By doing this, we provide a more complete CVE from the beginning and improve the way we handle vulnerabilities across the board. That's it for me. Thank you. I believe we have a question. I don't know if that mic works. There's no one in here, so I'm going to do it myself.
So my question is, my statement is, I agree with you. CNA should be self-enriching. Agreed. But what is the benefit to the CNA to do this? And more, because again, I'm sure there's a cost in manpower, time, etc. And what is the governance in place? Because if there's no real governance, no real rules or consequences to them not doing it, what's the enforcement action versus saying, please be nice to your customers, please spend this money on something that's not directly benefiting the CNAs and their companies?
So what I understood was, why should CNAs do this, right? Why should they self-enrich? What's the benefit of them doing that? And is there any rules behind?
Yeah. They should do, they should do this. It's good for their customers, but for the CNAs themselves, what is the benefit to the CNAs?
So I mean, I'm obviously only be able to speak on behalf of MongoDB, who is a CNA, and we issue CVEs or want to be CNAs because we get full control over what is being said about our vulnerabilities, and we have the most up-to-date information of our own vulnerabilities, right? So if we rely on other organizations like MVD, who have published and said that all their metadata inclusion is based on publicly available information, then they might not be providing the best information on those CVEs. And I don't know about anyone else who's in here and is a CNA, but we get a lot of questions from our customers like, why is the CVSS score so different on MVD? And why is it a critical here, but in your CVE, it's just a medium? That creates a lot of frustration within our customer support teams because, one, again, you have to explain what the CVE process is, and then explain to them NVD is a supporting body. They aren't a CNA. They don't have all the information. And I had a point to this. Now I've lost my train of thought. But yeah, so we are helping our customers by providing that information from the get-go. And with the MVD slowdown announcement, we knew, well, I tried to find out from vulnerability scanners themselves, are you using any other APIs to get these CPEs? Because if you're only using NVD APIs and they're slowing down and not adding CPEs, then where are you getting those CPEs? How are you going to identify those vulnerabilities on the system? I couldn't really, I mean, I only reached out to the vulnerability scanners that we actively use because they have a contract with us. So, you know, it was a lot easier to reach out to them. And they couldn't really give us a straightforward answer. They say, yeah, we use other things, but they couldn't tell me exactly what they use. But I hope I answered your question. Yeah.
Yeah, welcome to everybody's world. Would you be for MongoDB owning their own CPEs and controlling that data themselves that would be used by NVD and everyone else?
Is the question if we own our own CPEs or?
Would you be pro as a CNA owning your definition, your CPE definitions, and being able to control what versions are in there and how you assign them to CPE?
Well, yeah. Yeah, well, basically how MVD does it is that they take the affected versions already that's in the CVE and they like create those CPEs based on all the versions or what that affected version is. And they add those CPEs based on that itself. So they're basically, oh, sometimes, okay. Well, I can only speak for our own CVEs, and we found that the CPEs that they were adding, it was for the affected versions, and it should be, right? Because that's why there's an affected field in the CVE JSON file. And those CPEs should reflect that because that's the product identifier to allow vulnerability scanners to identify affected systems. So in a sense, yes, I do think that CNA should be adding CPEs because that way you kind of negate the potential customer questions of why is this affected if that's not what's listed on the CVE itself. So by adding those CPEs, again, you have control over what is being said about your vulnerabilities, right? Yeah, I hope that answers the question. Any more?
Do you know how many of the recently enriched CVEs with CPEs came from the CISA ADP versus CNAs?
No, I don't actually have that data. And I know Andrew actually covered this in his talk yesterday, but I haven't really the search was mainly for looking at JSON files that included CPEs. Actually, no, actually, yeah, sorry, correct me. I'm going to correct myself. My search in these JSON fields specified for the CNA container. And within the JSON file or the JSON schema set out by the CPE program, each section, the CNA enriches their own container. And then the ADP, they enrich their container called ADP container. And actually, so in the slide here, you can see containers. And when you're a CNA, you fill in the CNA container. And when you're an ADP, you fill in the ADP container. So the search that I used specified to look at CPEs under the CNA container. So all the data that I've pulled should be for CPEs included in the CNA container. So the assumption is that the CNA themselves added those CPEs. Okay, I think we're done. Thank you so much for joining.